Hi, welcome. Good evening all. So, welcome to the Mixed Nuts at Pramati. Mixed Nuts is a monthly event at Pramati in which we'll have a technical presentation on various topics that happens every month. So, as you all know, today's topic is closure through the eyes of a Java net. Myself, Kannan, I'm working as a principal engineer with Pramati. So before starting with the content, I thought it would be fair to give a brief intro about myself, whose eyes you'll be looking the Clojure through. So I'm a strong believer that OOPS is a natural way to design and solve the real world problems. And I read and chat a lot about Java features and Spring annotation. Sometimes I still do. And I'm still a Java developer. Most of the backend components that we are having are in Java, and I still think and code in Java primarily. I'm not a know-it-all Clojure guy, so I'm not professionally into Clojure yet. So Clojure is more of my part-time exploration. So I'm still one among the Java tribe and one among you. So this talk is not a Clojure versus Java comparison. If at all there are any comparison in this talk, that's purely meant to get the concept by contradicting the known example in Java. This is not a Clojure tutorial. You're not expected to go back home and start with Clojure right away. This is more of a personal experience on how I felt when I started with the Clojure. There might be a few opinions and some of the contents are subjective. So the intention is to throw light on the Java Clojure world for Java developers. So even if I'm able to inspire at least one of you to just go and look into Clojure and try out few things, I consider that as a grand success for this talk. And this talk will be a mix of slides and REPL showcases. And on REPL showcases, I'll shamelessly feel free to copy paste code and execute it to showcase whatever I have felt. These will be the topics that we'll be going through. In Clojure Primer, we'll have a short intro on Clojure so that you'll be able to feel the amusing and hard parts in the consecutive topics. And the amusing part is meant to share whatever the things that amused me in Clojure when I came from a Java background. And the hard parts or the things which I felt, which I struggled a bit when I came to Clojure from a Java background. And as I was exploring Clojure, I had, before I started my exploration, I had a lot of questions. And during the course of the exploration, I got answers for those questions. So those questions and answers will be there in the gotcha section. And at last, we'll have question section in which we'll have a discussion. Maybe what are the things, what are the questions that you have? You can ask it. If I know, I will answer. So to start with Clojure Primer, about Clojure is a dynamically typed functional programming language in Lisp dialect, which runs on JVM. So you'll be creating a jar artifact from a Clojure project in the similar way that you do for Java projects. Let's move on to syntax. I'd like you to pay close attention to the Clojure syntax. So we'll be using this in the upcoming slides. So that's how the Clojure syntax is. So any Clojure expression that you see will follow the syntax. You'll have operator followed by the operands enclosed within the parentheses. So an operator can be a special construct or a function or a macro. Let's see what those are. A special constructs or built-in language features. For example, you can think it as keywords that we have in Java, something like public, class, int. So you don't have any idea of what exactly it's until you take a stand to dig through into JVM implementation, and you don't have, you'll not be able to define the special constructs by yourself. Functions are something which you can equate to methods in Java. Function is something which may or may not accepts multiple arguments, do something, may or may not returns a result. We'll see what a macro is in the upcoming slides. And the next thing is evaluation model. So this is a oversimplified evaluation model. So this is just to give a mental model of how Clojure expressions will be evaluated. This is not an exact evaluation model. So just keep in mind that this is just to give you a feel of how the evaluation happens. So as we have seen earlier, so we have seen how a Clojure expression looks like. So whenever you're evaluating a Clojure expression, assume there is something called as a Clojure evaluator, which accepts a Clojure expression, executes it, and may or may not return a result. And if a particular operator is a macro, it goes through an additional layer called macro expansion. So whenever that operator is a macro, it goes through 2 levels of execution. So in macro expansion, what happens is, what are the operands that you pass to your macro? So you have the ability to write macros. So what you'll do when you're writing a macro is, you accept the operands for that macro, you do whatever the manipulation that's needed, and you return a Clojure code from a macro, which will be evaluated by the Clojure evaluator. So when it's a normal expression, it will be evaluated by the Clojure evaluator. When it's a macro, it goes through macro expansion. As a result of macro expansion, you will have a Clojure code, which will be evaluated by the Clojure evaluator. Let's move on to amusing parts. So the first thing is simple syntax. As mentioned earlier, all the Clojure expression follows the simple syntax of operator followed by the operands. So let's see some of the expression to get a feel of it. For example, if I have to add multiple numbers, I'll say like this. If I have to associate a value with a reference, I'll say this. If I have to compare a value with another value, I'll say this. If I have to is it visible? Hello?
Yeah, it's visible now, Kannan.
Yeah, okay, fine. Okay, let me start this one from the beginning. So if I have to add multiple values, I'll say this. If I have to associate a value with a reference, I'll say this. If I have to do a equals check, I'll say this. If I have to write a if case, I'll say this. So as you see, when I evaluate this expression, you get the value as equals, since the value of v1 is 1. As you see in all of these expression, the syntax is consistent. You have operator followed by operands. So this is consistent across all the statements. And if you take the case of if-else statement, you have if is the operator followed by the operands. So the first operand is a condition, and followed by the operand, which is the true condition. So which will be evaluated in case if the condition is true, and the last one is executed if the condition is false. And all those operands within a if expression, that itself is valid Clojure expression, which follows the same syntax: operator followed by the operands. So as you see in all these examples, the syntax is valid across Clojure's expression. So it will be operator followed by the operands. And the next thing is less special constructs. As we have seen earlier, special constructs are like basic building blocks of a language. So in Clojure, there are it's like hardly some 13 to 15 special constructs. So based on how you categorize it, sorry. So you might even get a feel like it's possible just to take all those 13 or 15 special constructs and build the whole Clojure language by yourself. It's possible, but I haven't give it a try by myself. Probably sometime later. So to give a feel of, I have written a snippet in Java and Clojure to calculate factorial. So whatever you see in your left is a Java code. I have underlined all the special constructs. As you see in the Java code, there are like 10 special constructs. So a public, static, int, if, and the rest of the things. So basically, we don't have any idea of how those things are implemented. And it's also not possible to implement those special constructs by yourself. Whereas in case of Clojure, only the if is a special construct. So you'll not be able to implement if by yourself. But the rest of the things that you see in the code, it's possible that you can define it by yourself. We have an example in upcoming slides to see how a logical operator can be implemented. And the next thing is infinite or lazy sequence. So what I'm doing is I'm printing. What I'm printing is I'm taking two elements from a list. As you see in the right, 0 and 1 got printed. So this is straightforward, right? So now I'm going to do a minor modification in the code. I'm just replacing this list with another function called range. When I execute it, I'm getting the same result. So what I'm doing is instead of taking 2 from the range, 2 from the return value of a range, I'm trying to take 20. So as you see, you'll be able to get first 20 elements from whatever is returned from the range. So it's even possible that I'll be able to take 20,000 values from the range. So as you see, I'm getting first 20,000 numbers starting from 0. So initially it might be difficult what exactly that range is returning. So what range is returning here is, it returns infinite lazy sequence. So on which take will be able to take as many numbers as it wants. And one cool thing about, so you might be thinking that what's so cool about it? We are having streams in Java. So the cool thing about it is like lazy sequences are so common in Clojure. As you have seen in the snippet, so take works for both a normal list and a range. So in case of Java, it's like streams is a separate hierarchy and collections is a separate hierarchy. You'll not be able to use it interchangeably. So that's cool thing here. And so because of this, you'll be able to defer the execution until it's actually required. So whenever possible, you'll be able to return a lazy sequence so that you don't do the computation until it's actually required. So the next thing is program as a data. So before getting into this, I'd like to introduce two new constructs in Clojure. So I have just created a list and printed it. There is another way of creating a list. It's like you can just put this symbol before this parenthesis, and when you say it's equivalent to the previous expression. And there is one more thing. So what I'm doing here is I'm just having this expression plus 1, 2, 3, plus 1, 2, and I'm printing it. As you see in the right, this expression plus 1, 2 got evaluated to 3, and the result got printed. So there is an operator called quote. What it does is it tells the Clojure evaluator not to evaluate the following expression. So as you see in the right, that plus 1, 2 is not evaluated and it's just returned by the evaluator and it got printed as is. So there is a short form of writing this. So what you can say is you can just put the code symbol. So this works same as a code. Okay. So now what I'm going to do is I'm just taking first element and printing it. It got printed. So if you see, what are the expression that you're having here is like a valid Clojure expression. And if you just put a code before it, it's treated as a list. Okay. Like whenever you want to have a list data structure in your Clojure program, you code it. And whenever you want to evaluate it as a normal program, you don't code it. So it's like your whole Clojure program itself is nothing but a nested list and nested uncoded list. So if you want list data structure, you code and use it. If you don't want to use it as a data structure, if you ask the evaluator to evaluate it, you just don't code it. So it's like your whole Clojure program is nothing but a nested list. So this property of programming language in which your whole program can be represented as a data structure on its own language is called homogeneity. So this has other implications such as metaprogramming, which we'll be covering in the later slides. Homogeneity. So the next thing is macro revisited. So we already have an intro to macro, and we have gone through oversimplified evaluation model. As we have seen, macros goes through a 2-level of expansion. So in the first level, maybe instead of expansion, we can say 2-level of evaluation. In the first level, your macro will be expanded. In the second level, your macro will be evaluated by the Clojure evaluator. So as you see, so it's possible that you define a macro, you pass whatever the parameters to the macro, you do any manipulation on the parameters that you're passing to macro, and you return a Clojure program. It's like it's possible for you to plug in an additional translation layer. So it's like you can define your own macro with your own grammar, and you define that macro in such a way that for a particular grammar, return this particular Clojure code. So these kind of features gives you a flexibility of defining DSLs, means domain-specific languages, and it also lets you create syntactic abstractions. Syntactic abstraction, by syntactic abstraction, what I mean is, it's possible that you can create your own custom syntax using a macro, which will be returning equivalent Clojure code and evaluated. So once you get comfortable with macro, things like enhanced switch in Java 13 doesn't excite you much, because it's very well possible that all those syntactic abstraction and syntactic sugars, you'll be able to create it by yourself with macro. So just to give a feel of it, what I'm going to do is I'm going to define a short circuit OR by myself. Okay. So you might be wondered in the previous example, like how the operators like or is not a special construct. I told it's not a special construct because it's possible that you'll be able to define it by yourself. So I'm just initially going to write few expressions. Short circuit OR. Before writing it, we'll write the expression and we'll write what's the expected output of it. So I'm going to define this operator. So when I just don't pause anything, I expect it to return a nil. And when I pass some values, I expected it to return a first non-nil or non-false value. So nil is like equivalent to Java's null. So here in this expression, I expect it to return 1. In this expression, I expect it to return 2. So when I evaluate it, I got runtime exception. That's expected because just a minute. I just need to clear this REPL so that you'll be able to see it clearly. So this exception is expected because so as you see here, the first expression got returns nil as we expected, and the second expression returns 1 as we expected, and the third expression returns 2 as we expected. Next thing, code.async. Code.async is a library under Clojure umbrella. It lets you do CSP style of programming. CSP means communicating sequential process. So CSP defines basic building blocks and constructs, which lets you create process, and it lets you communicate within those process without much hassles. It's like error-free method of doing inter-process communication. So in programming language term, maybe inter-thread communication. So CSP is completely backed up by a theory called PyCalculus. Maybe if you're interested, you can dig through it. With code.async, we have two major constructs called Go blocks and channels. Go blocks are comparable to threads in Java, and channels are comparable to blocking queues in Java. I said comparable because it's not exactly same. So it has more sophistication than just having a thread and blocking queues. A special highlight feature is all tests in code.async. So what all tests offers is it lets you wait on multiple channels. So whenever a result arrives at a particular channel, all test takes that result and just stops the program there. So it just returns it. So it's like assume that you have some function or operator in Java which lets you wait on multiple blocking queues. Assume that if you're able to take a result from a queue, whichever gets the first result and returns it. We don't have out-of-box support for that in Java, but that's how it feels like to use all tests. So the next thing is code.logic. Code.logic is another library under Clojure umbrella. It lets you do constrained logic programming. So with constrained logic programming, what you'll do is you have constraints. So for example, if you have a problem statement which is based on constraints, you'll say these are my constraints, and you won't say how to solve that problem. So your language or framework has generic algorithms which takes care of solving those constraints and returning the results for you. So at a high level, you'll say, this is my problem, and you won't say how to solve your problem. And there'll be generic algorithms which will take care of solving your problems for you. So a famous language is like Prolog. Prolog is famous for CLPs. So you'll be able to do that in Clojure using code.logic. Classical applications of CLP are like endpoints, Sudoku, and timetable creation. So in all these problems, it's like you have constraints. Your problem statement itself is defined by constraints. So once you're able to get a solution that solves your constraints, you solve that problem. So just to give a feel of it, this is a snippet of a Sudoku solver in CLP. So I have just, so apart from this, there are hardly some 15 to 20 lines of code to solve Sudoku. So I have just underlined my constraint definitions here. So whatever I'm saying first is I have vars which contains all the variables in the 9 by 9 matrix of Sudoku. So what I'm saying is in the first line that I have underlined, I'm saying the variables should be in the range of 1 to 9. No other numbers are allowed. And in the second line, what I'm mentioning is all the rows should be distinct. So it's like no single number can occur more than once. I'm applying the same constraint for columns and squares. So once I give all these constraints to the operator run, it solves those constraints and it returns you the solved Sudoku. So actually, it's more fun to do CLP. It's something which we never have hands-on in the mainstream programming. And the next thing is code.match. Code.match is another library under Clojure umbrella. So it lets you write sophisticated switch case style matchings. As an example, you can write a match statement like this. So what we have done here is like we have three variables x, y, and z. So based on a matching expression, I'm returning some value. For example, the second line says for any x, and if y is 1 and if z is 2, return 1. And in the fourth line, what I'm saying is for any x and any y, if z is 2, then return 4. And the last thing is a default case. And one more cool thing about this is not just for primitive data types. So you'll be able to do these kind of matching for collections like list, sets, or maps. And it's also possible that you'll be able to match multiple values for a given variable. And you'll be also able to write regular expression matching. You'll also be able to define custom function which does the matching for you. So all sorts of the sophistications are available with code.match.
What is the
yeah?
What is the square? Is kind of like something like square bracket?
There is a data structure called vector. Yeah, it's comparable to array list in Java. So the next thing is isomorphic. A language is said to be isomorphic when it has ability to run both on server side as well as in browser. So one of the main power of Node.js is this. So if you know JavaScript, it's possible that you'll be able to code server as well as for browsers. So Clojure has isomorphic counterpart called Clojure script, in short CLJS. So it's possible that you write a Clojure code and you compile it to JavaScript and execute it for browsers. And a lot of people use this in production. And and a cool thing about this is like you'll be able to inherit all the goodness of Clojure and you can use it for browser programming. It's like you'll be able to write logic programming and CSP style of programming all for browsers. And the next thing is conciseness. You might have noted in the previous examples, like most of the Clojure programs are concise when compared to its Java counterparts. So it's like Clojure is less verbose, short and sweet code, and conciseness is mainly powered by the syntactic abstractions offered by the macros and more abstract implementation and reusable functions. To get a feel of it, let's see some examples. So this might be something very new for Java developers, but probably if you have some hands-on in Python, you might have used this. So what I'm trying to do is I'm trying to do a Cartesian product of two lists. As you see in the right, with just one line, we are able to do a Cartesian product of two lists. So for your information, this syntactic abstraction is offered by power of macro. So for is a macro. And the next thing is there is a function called slurp. So what it does is it reads a file and returns content of the file. You might be thinking that what's so great about it? So we have something called files.readline. So a great thing about it is I have hosted the same file in HTTP server. As you see here, Slurp will be able to read it from HTTP. And next fun thing is I have hosted the same file in FTP server. Slurp will be able to read it from FTP. So it's like most of the functions in Clojure are like so abstract that it works for it's like, for example, in case of Slurp, you don't have to have different functions for different source of file sources. So that's something great. And this is a classic example which most of people use to showcase Clojure conciseness. So what I have defined just now is it's a lazy sequence of Fibonacci sequence. So it's a lazy infinite Fibonacci sequence under 50 lines. Sorry? Yeah, it's recursive. So just to showcase it, so is the REPL visible or should I clear it? Yeah, okay. So as you see, you are seeing the first 20 numbers in the Fibonacci series. So it's like you will be able to write a Fibonacci sequence program along with a command, and you can treat it.
Lazy cat is
So everything that I'm working with is available out of the box. So I haven't included any library. I started from a scratch. So whatever I'm using here is are constructs available out of box, except those libraries that I have mentioned, something like code.logic or CSP. Everything that I'm using in REPL is available out of the box in Clojure.
Right. So the lazy cat here is it a construct or is it a macro or something different?
I think it's a macro. Yeah.
And how do we do imports, like whatever we do in Java, right? How do we?
Sorry. Sorry. Hello. Hello.
Hello.
Yes, Arun.
Hello. Can you hear me?
Yeah. Yeah. Tell me.
How do you manage third-party libraries?
No, since Clojure is, runs on JVM, so it's like you'll be able to import libraries from Maven repositories.
Okay. So adding to the code is like just Java import, something like that.
Yeah. Not exactly Java import. So it's possible for you to import jars from the Maven repository. So it's based on which framework that you use. So or which build tool that you use. So basically it's equivalent to Maven or Gradle that we use in Java.
Okay. Yeah. But inside the code, how we import the package?
Similarly, we have import in Java. We have some keywords like require or use in Clojure.
Oh, we have.
So using which we'll be able to import. Yeah, that will be explained in the upcoming slides. I have it. I think it's time for a break. We'll assemble after a 15-minute short break.
We have refreshments arranged.
Sorry. Yeah, to repeat your question, so the question is, are we using Clojure Introduction in Pramati? So not yet.
You recommend it for
Yeah, actually, there are a lot of people who are running Clojure in production. It's like there are few companies which only runs on Clojure. So it's being widely used. So basically, I'm not in a position like I can strongly say you can use it or not, because I'm more like a learner. So it's like I'm hardly around 150 or 200 hours away from you in Clojure. So can we resume? So the next I'm using thing is memoization. So memoization lets you wrap your function so that once you call your function, the wrapper takes care of calling it for the first time for a given argument, and for the consecutive times, it won't execute your function, and it will just return the result which is already being cached on the first call. So basically, it's like a reusable caching implementation which you can use for almost any function that you have it in Clojure. And so the main leverage comes from a property called referential transparency. So referential transparency is a property of most of the functional programming. Pure functions in functional programming. So what I mean by referential transparency is, so if you have a function for a given parameter, the result, the return value of a function stays the same irrespective of when you call it. So because of it, it's easy for you to memorize your function whenever possible and applicable. So just to give a feel of it, I'm having a function called search. So what it does is it accepts any argument, it does a Google search and returns the result. So what I'm going to do is I'm going to execute the search on a string called Clojure. So and I'm going to calculate how long it takes. As you see, it takes around 1400 milliseconds. So when I run it multiple times, it takes around a range of 120 to 250 milliseconds. Whatever you see here is like the time it takes to execute a particular function. So what I'm going to do is I'm just going to add one keyword here. And redefine the function. So when I call it again, it takes 411 milliseconds. On the consecutive call, it just takes less than 0.1 millisecond. So what happened here is when I just add this keyword memoize, the first time it executes the function and caches the result. On the consecutive calls, this memoize wrapper takes care of returning the result which is being already cached. So maybe if I change the keyword to something else, the first time it takes more time. On the consecutive runs, it takes very less time. So with just one word, it's like memoize is like a reusable caching implementation, which you can just implement very easily. And whatever the example that we used here is not a recommended usage of memoization, because this function search is not a referentially, it doesn't have a property called referential transparency, because search results from Google is not assured to stay same for every search that you do. So this is just for a showcase purpose. So you're not recommended to use memoize in case of functions like this. So the next cool thing is Java intro. As we had a question from our audience. So since Clojure runs on JVM, it's possible for you to use Java classes and functions. So with all the goodness that Clojure offers, it's possible for you to inherit the goodness that you used to in Java. Just to showcase how it works. So I have just currently used system.currentTime millis, the static method that we typically use in Java. So what I'm doing now is I'm creating a new hash map, and I'm adding a key value pair. As you see in the right side, I have created a new hash map with key as one string and value as one. So like this, it's possible for you to use Java classes and methods here. And it's also possible for you to create classes out of Clojure and have it usable in your Java programs. So now we are done with the amusing parts. Let's move on to hard parts. So the first thing is usage of parentheses. So you might have seen that we have used a lot of parentheses in the example snippets that we have shown. And you might be wondering what's so hard about it. Similar to the curly braces that we have in Java, here we use parentheses. But the thing is, it's not like that. You will not be able to use parentheses arbitrarily as you do as you use curly braces in Java. For example, the first expression that we have +1, 2, 3 cannot be rewritten as +1, 2, and 3 enclosed within parentheses. That's not possible. So to overcome the usage of hardness and usage of parentheses, you have to understand that each parenthesis is like an unquoted list which will be passed to Clojure Evaluator. As we have seen in the simplified syntax, so after parenthesis, the first element is expected to be an operator. That's why you'll not be able to use parentheses arbitrarily. Expressions like this are not possible. And the next thing is to overcome a visual difficulty in using parentheses, try using any IDE which does the code formatting for you, and shift to S expressions. So this syntax, whatever you use in Clojure, operator followed by operands. So this also called as S expressions. So this shift was initially difficult when I started with Clojure, especially when the order of the operands mattered. For example, whenever I was writing conditional statements like this, I used to think like, so initially when I see this, see the expression, so this operator followed by 2 and 1, I used to think like if you are comparing, if 2 is smaller than 1, but actually it's the other way. So in my mental model, it's like whatever the nose is pointing towards, you are checking if that is a small number, but actually it's the other way. And the same holds for this condition. So to overcome difficulty in usage of S expression on operators like this, you have to unlearn whatever the conventional meaning that you have, and you have to read the docs properly. So for example, this operator checks if what are the following operands that follows or in descending order, and this operator says if what are the following numbers that follows the operator or in ascending order. You have to practice. And the next thing is immutable data structures. So all the code data structures that you have in Clojure are immutable. A list, map, vector, or anything that you have in Clojure are immutable. So it's like once you created a list or vector, you will not be able to change elements in that particular list or any collection for that matter. So being from a Java background, it's the most difficult part for me in Clojure. So we are all the time we are used to iterate through list or array and change or manipulate as we wish. And because of this, implementations like dynamic programming are very difficult. So because with dynamic programming, what you do is you calculate few results, have it cached in some list or map, and reuse it in the upcoming iterations. So since code data structures are not mutable, you will not be able to do it easily. So in use cases like dynamic programming, this immutable data structures was very difficult. So to overcome it, even though you'll not be able to mutate it, it's possible that you can reassign a reference with the changed data structure. So but don't do that. So don't go with working around immutability. So that's more like doing. So it's like you'll not be using a full power of functional programming. And in Java, we naturally think in terms of loops. Instead, when you move to Clojure or any functional programming for that matter, think in terms of map, reduce, and recursion. So that will help you to overcome the difficulty of using the immutable data structures. And in case of dynamic programming, Memoize will help you to leverage on, give you the feature that you need. So it will help you to cache a result for a particular parameters, and it will help you to leverage on those things. So the next thing is programming with macro. So initially it takes some time to get a significance of macro. So you might be finding it difficult to initially to get a mental model of what exactly is a macro and what's a function and what's the difference of those two. And also the choice of using a macro was a bit difficult. And also, as we mentioned earlier, macro goes through two levels of execution. So if you have some statement within a macro definition, it might be initially difficult to get a mental model of where exact in which level of evaluation a particular variable or expression gets evaluated. So to overcome the difficulty of macro, maybe you can try implementing some out of the macros available in the language by yourself, similar to the short circuit OR that we have shown earlier. So maybe you can try implementing one by yourself and just compare it with the existing source code and see how well you are doing. And on the choice of macro, use macro only for the syntactic abstractions. So whenever you have a possibility of using a function, go with a function. And with respect to the scope, try getting a mental model of a two level of execution. So once you practice more on it, it'll be easy. And the next thing is lazy sequence. Similar to macro, lazy sequence is both amusing and hard. So means if you have followed closely, it might be difficult to get a mental model of what exactly the range does there. So it's also a bit difficult initially to write a lazy sequence one by yourself. So when I tried it by myself, it took around some 2 to 3 hours to write a 4-line of code which returns a lazy sequence. And to overcome it, you have to understand that the power of lazy sequence lies not just within the code which produces the lazy sequence, it also lies within the code which makes use of the lazy sequence. So what are the operator similar to take that we have seen earlier? So take is implemented in such a way that it works both for normal sequence and lazy sequence. So you have to understand the power lies in both. And the next thing is gotchas. So in this section, we will see some of the questions which I have foreseen. So these are the questions which I had myself and which I got clarified as I explored more on Clojure. So when I mentioned about core data structures are immutable, you might be thinking like that's crazy. Even simple things like addition or deletion are not possible in Clojure. So the answer is Clojure does supports those operations, but it doesn't change the original data structure. So this might be confusing. We'll just see it with some examples. Sorry? Not exactly. So what I'm doing is I'm defining a reference called A with elements 1, 2, 3. Okay. Now what? So as you see in the right, A got created, and I'm printing A. As you see here, A has elements 1, 2, and 3. So now what I'm doing is I'm appending element 4 to A. As you see in the right, 4 got appended to A. Now you might be thinking that I have cheated you that because we are able to append elements to a vector which we have created. But the thing is, once you again print A, you see the A is unchanged. So what happens is, in this statement, 4 got appended to A and the result got returned, but that operation doesn't affect CA. So which means we will be able to do operations, but that operation doesn't affect the data structure on which we operate on. This is what we call as immutability. So now you might be thinking like for each simple operation like appending or removing, you'll be creating new data structures. That's crazy because we'll be filling up the memory unnecessarily. But the answer is no. We'll not be filling up the memory unnecessarily because Clojure uses a mechanism called persistent data structure, which doesn't actually create a new data structure for each operation that we are doing, but it will be effectively reusing whatever is already created. For example, here we have created A with elements 1, 2, and 3. When I say conj A4, so this returns a new data structure with elements 1, 2, 3, and 4. So the 1, 2, and 3 will be reused in the memory which has allocated to 4. So maybe you can compare it with what we have in Git. So we have Git commits, right? So each commit, we'll be just tracking the changes. So it's possible that you'll be do Git checkout, you'll be able to go to a commit and you'll be able to see the whole source code. It doesn't mean each commit contains the complete source code of all the files. It's like for each commit, we'll be just tracking the changes, but it will be possible for you to go to a commit and see the whole source. And the next thing is, so when I explained about the conciseness, you might be thinking that anyhow, what are the Clojure code that we are writing will at last be compiled to jar, and which internally contains .class files, which might be ended up creating so many number of lines of code. Probably might be more than more number of lines, even if we have written it ourselves in Java. So you might be thinking that what's the point of having a concise code? So programming with less code probably means more productivity. So I'm not saying less code equates to more productivity. It's probably means more productivity. And but surely it means less testing. For example, if you have some functionality which you are able to write it in 100 lines of code in Java, and if you are able to achieve the same functionality in 10 lines of code, that surely means you have to do less testing for a 10 line of code compared to the 100 line of code. And when I say 10 and 100, you might solving a program called Convoy's Game of Life in are you able to see? Okay. So I tried solving a problem called the Convoy's Game of Life. So someone solved it in Clojure in 7 lines of code. I tried solving the same in Java. The max that I was able to reduce was around 90 lines of code. I wasn't able to go beyond that. So it actually means I have to write more number of test cases for 90 lines of code compared to the 7 lines of code. So in some cases, it is possible that you will be able to achieve orders of magnitude in the conciseness. Yeah. Sorry?
No, I wanted to ask you a question.
Yeah.
The thing is, I accept like less code is more productivity.
Yeah.
For programming, what about employee? Like you said you were able to do it in 90 lines of code. How much how many lines were there when the
7 lines, yeah.
7 lines of Clojure got compared to
I didn't count it, but most of the times it happens like we tend to over-optimize things, which is not actually required. So as stated, it's like premature optimization is root cause of all evils. So it's better not to go for optimization upfront before hitting the bottleneck.
Yeah, that does apply for some cases. Yeah, Clojure has its own possibility.
Yeah.
At some cases, it won't be better if you write in Java because the number of lines. Say if my use case is modeling a lot of data, then in that case, I wouldn't go for Clojure. Better I would go for
So as I mentioned earlier, I'm more of a beginner in Clojure. So I'm hardly like 150 or 200 hours away from you in Clojure. So based on my experience, so these are the amusing things that I had. So I'm slowly experimenting with multiple stuffs. For example, the Convoy's game of life that I mentioned. So in my pipeline, I have still more use cases. Like I'm planning to develop some applications in Clojure and Java and see how exactly it performs. So probably I'll share it once I'm done with those.
But whatever, like, whatever you know for now, what do you think is the best case?
So yeah, so means if I am thinking now, for example, in one of my previous project, we built a module which prepares data for a machine learning module. Okay, so what happens is like I used to write sequels, and each sequels are like around 250 to 300 lines. Okay, so I had to write around 20 to 25 of those sequels. So if I have known Clojure by that time, probably I would have gone and probably I would have chosen a DSL. I would have written a macro which helps me to abstract out those sequels. I would have been able to write a DSL. So in which I'll write a DSL for around 10 or 20 lines, which generates the 200 or 300 lines of SQL.
That would have been awesome. Like, you could have greatly reduced the programming session.
Yeah. Any questions? Any other questions? So, any other questions from the remote people?
How long will it take to
Sorry?
How long will it take to get used to this? Just asking you.
So actually, my comfort. So the question is, how long will it take to get comfortable in Clojure? So for me, it's like I recently took a challenge called 100 days of code. So the challenge is like for continuous 100 days, at least for 1 hour, I'll read, write, or practice Clojure. So it hardly took around first 20 days for me. So it's like there is a rule called so in 20% of time, you'll be able to achieve 80% of mastery. There is a rule called 2080. So all it takes is first 20 hours for you to get comfortable. So means to get the ultimate mastery, it might take thousands of hours. Yeah.
Is there any pattern you follow that you want the facts first, then follow the practice, and some problem statement, then proceed with the code process? For a beginner to start with, what
Okay.
pattern should we follow?
Okay. So the question is about the learning pattern that this 100 days of code challenge. So what I had is I didn't have any hard rule like I'll do all these in these many days. So I just stick to the process. So my concentration was just to spend 1 hour on it. So with that, without any frustration of achieving a particular goal, just with the process. So I just stick to the process, and the process helped me to achieve whatever I have done. So probably in that 100 days, in the first 20 days, I was able to complete a book along with the practice problems. Means I didn't practice all the problems, but I practiced some of the problems. But at the end of 100 days, I was able to write around some 2 or 3 blogs, and I was able to contribute some of the open source projects.
So I have a few questions.
Yeah.
So the web server
I tried developing a web service endpoint with Pedestal, but I can't confidently say I have developed a web service. Yeah.
How many use cases are also using the web server?
Clojure using a?
The enterprise level people. So if you find any people who are using the enterprise level.
And people using Clojure at enterprise level.
Yeah, so on people using Clojure at enterprise level, I think there are a few companies out here, at least in Chennai, which I know they are using. So yeah, means internationally there are a lot of people using. So the main company is Cognitech. So it's by it's headed by Richie, creator of Clojure. So they use Clojure completely.
So it's not JV, right?
Yeah.
It doesn't just in runtime, right? No, Java is okay.
Yeah, Clojure runs on JVM.
Git, right?
Yeah.
So lots of language are written on behalf of Java, like for Scala and Disclosure, right?
Yeah.
So it's faster in Java.
So on your question on if Clojure is faster than Java, I haven't done any benchmark by myself. So as I mentioned earlier, most of the time the optimization might not even be required for the use cases. So it's based on the use cases. So probably I'm planning to do some. I'll share it if I have them.
Okay. So when it comes to Scala, I think the problem is SPT. So it takes no much time to build it.
Okay.
So you use RTL to be faster. So you need set up any big project that you have lots of validation closer that possibly right. So that closer like this can be hosted in any.
Yeah.
So if you ever try to do it,
so on the question of if I have ever tried building a big Clojure project, no. I'm repeating the question because this will be, so you will not be audible for the remote people. So I'm just repeating the question in answer. Yeah.
so you article here answer question so you have to put the transfer like the JS6 to ESPS, right? Like a transfer which actually convert the closer code to JavaScript, right? Did you ever try that?
I just tried building a sample app, which they, so on the question, so the question is if I have ever tried doing Clojure script by myself. So there is an example out there in the Clojure script page, in the official page. I just tried running that hello world and I have seen how it works. That's it.
So that's my question. Every time I serve with purpose, right?
Yeah.
So what the purpose is now actually?
Yeah, so the question is on what's the purpose of Clojure. As I have mentioned earlier, I'm more of a beginner. So I can't answer it out of my own experience, but based on what I have read, so Clojure is functional. So it helps you to achieve, so basically functional, there is a concept that functional languages are better so when you have applications which are concurrent intensive. So functional languages are good to go. And also what I would say is you have a version of these different paradigm of programming like CSP, CLP, all those things are available for Clojure. And apart from that, one thing that I love in Clojure is macros. It lets you do syntactic abstractions. So it lets you do a program in a different level, something which you haven't used to in other languages. So this is available in all the lists as I know. So that's something which I love.
That is for ML library.
Okay, so the question is if there are any ML libraries. I'm not sure. So I have bookmarked some of the articles which says deep learning for Clojure developers. So I need to go through it.
So they actually know they always go with the same flow on it.
Okay.
Before the stage and they implement that in customer space.
Okay.
People knowing the customers, then they get the benchmarking, then they will know they post the technology that every month.
Okay.
So they go there and this is my last stage.
Okay. Okay, probably I need to explore more on that. Yeah. Any other questions? Any other questions from the remote people? Yeah. 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 I think since there are no more questions, yeah, I think we are good to close. Thank you all.